It's question show time. Your questions, my answers. As always, wherever you are across my channel, question pops in your brain, just write it down. I'll gather them up and I'll answer them here. I hope you had a somewhat relaxing summer considering the current global events. I know I did, relatively speaking. We've got, but if you're like dying for content, buckle up because it's all coming back. By the time you watch this, the first episode of the Weekly Space Hangout featuring Dr. Katie Mack will have already happened. After that, we've got an interview with astronaut Terry Virts. My live shows are coming back every week. Plus, we're adding a new guest live show. So I've got the Fraser QA plus a guest show every week, plus the Guide to Space videos and some longer stuff coming. So I hope you're ready for a mountain of space content. This week, we've got a special guest answerer, astronaut Terry Virts, who will answer someone's question about astronauting. All right, let's get into this week's questions. Abdulrahman Samud, what is the name of the star that went supernova and created the solar system? Do we know anything about it? The vast majority of the solar system is the sun, and the sun is mostly hydrogen left over from the Big Bang. So it wasn't a specific supernova that created the solar system, it was the Big Bang and all of the hydrogen and helium that was formed in that event. That said, there is additional material that was supplied by various other events that happened over the millions and billions of years of the length of the universe. And so you're going to get all kinds of stuff, adding extra little ingredients to the mix that made up the solar system. You've got stars like our sun that are dying before our sun is even born, that are blowing off clouds of carbon into space. You've got supernovae that are detonating and spreading out material into the universe, some of which is seeding the solar nebula to help provide material for the solar system. But we don't know any specifics about any of those events because they happened before the solar system itself was born. That said, astronomers actually fairly recently were able to figure out that there was probably a kilonova in our environment about 100 million years before the solar system formed. And so a kilonova is when you've got two neutron stars that are orbiting around each other and they collide. And they provided about 0.3% of the heavier elements that we see. And when you sort of examine an average human body, I think one eyelash of a human body is from that kilonova event. And actually the vast majority of that material was iodine. Iodine? I'm not trying to say it. So that's one that astronomers were actually able to figure out specifically. And they were able to do that by looking at the isotopes of radioactive elements in meteorites that were found here on Earth that had formed at the same time as the rest of the elements in the solar system. And so the astronomers think that this kilonova event happened about 1,000 light years away from us, blew up, sprayed some of these heavier elements, iodine, gold, other stuff into the solar system that helped, again, just more ingredients to make our solar system just a little more flavorful. Fugel, hey Fraser, question for you. Just rewatched The Martian, and whilst Mark Watney was performing self-surgery, it occurred to me to wonder if he'd get an infection like we would on Earth. Before antibiotics, people died from the tiniest wounds on Earth. But would the same apply for Mars, or would the lack of a biosphere mean unless we took the bugs with us, it'd be a lot safer to suffer surface cuts and wounds? Thanks. I totally forgot about that scene. I think it was based on a real life situation where like a doctor had to perform surgery on themselves in Antarctica. So no, we will not be protected from infection when we leave the Earth or go to places like Mars. The problem is that we carry our bacteria that gets us infected with us. It's on our skin. Now, most of our skin is fine. It's like a desert of bacteria, but on your palms, in the sort of inside your armpits, inside your elbows, behind your knees, in your mouth, your nose, your eyes, we're swarming with bacteria. And that's the stuff that can make its way into cuts and can infect you. In fact, about like 1.5% of people have extremely antibiotic resistant bacteria in their noses. So you're carrying around the stuff that'll get you infected. But most of the time, it doesn't cause a problem because your skin protects you, and even if your skin doesn't protect you, then your immune system protects you, and it's only if those layers of defense don't protect you, then the bacteria can get started and start an infection. And so no, unfortunately, we will still get infections in space and on Mars. Zaz, question, when a neutron star becomes a black hole, is the star itself still there inside the black hole, or are all the neutrons torn apart when it's forming? I know we cannot see inside the event horizon, but there must still be a lot of compressed mass in there. The black hole must be composed by something to still be a black hole, right? Any theories? I think the way you describe that as a neutron star becoming a black hole is a really great model to wrap your head around a bit of what a black hole is. Imagine a neutron star, the remnant of a supernova that it's exploded. It's got several times the mass of the sun. It's compressed down to an area the size of like a city. Gravity is incredibly intense, but the gravity is not so much that light can't still escape from this object. And so a neutron star can shine. But imagine, say, the neutron star is continuing to feed on some other stellar material, and it grows and it grows and it grows, and at some point it crosses some line where the escape velocity off the surface of this neutron star has exceeded the speed of light. And in that moment, it collapses into a black hole and disappears, because now not even the light can make it off of this neutron star. And so then you're wondering if that just happens, if it goes just from neutron star to black hole, is there still a thing inside the event horizon? And the answer is nobody knows. Sorry. Logically, maybe, but then we don't know if you cross that line, if something happens to the state of matter. I mean, a neutron star is already at the point where it is compressed, where really all of the protons and electrons have been mashed into neutrons, and it just refuses to be compressed anymore until it does. And then at that moment, all bets are off. Is there some object that's more dense inside the event horizon? Maybe. Or does this object just continue to compress down? And maybe it accelerates as it compresses, getting smaller and smaller and smaller. Astronomers still have no idea. When astronomers deal with black holes, they deal with them mathematically. They imagine an object of a certain amount of mass, say 10 times the mass of the sun, but compressed into a region of infinite density. Now, it might actually be infinite density or approaching infinite density as the black holes continue to compress down and accelerate, or maybe it's some set size. But mathematically speaking, astronomers deal with it just that it is a singularity. Paul Wheeler. Hello, Fraser. I have a question. It made my brain hurt with this the other day. If the universe is infinite, as some say, why would the CMB be where it is? Wouldn't it be at the outer edge of everything? Thanks for all you do. All right, so the CMB is the cosmic microwave background radiation. This is the radiation left over from the Big Bang. When the Big Bang happened, the entire universe was incredibly hot and dense, but as it was getting less and less dense over time, it cooled down to the point that light could finally escape. And so when we see the cosmic microwave background radiation, what we're seeing is that moment when those photons were able to leave. And here's the part that's kind of interesting about the CMB, is that we're actually seeing a different cosmic microwave background every second that goes on, every minute that goes on, every year that goes on. The sphere that we can see out into space gets 1 light second bigger and 1 light second bigger every second. And so we're seeing a brand new region of space that is emitting that cosmic microwave background. And as the universe just gets older and older and older, we will see the birth pangs of the universe at a farther and farther distance. And so that's why you're not seeing it out to infinity. You cannot see before the beginning of time. Ming on Mongo. This is a good example of why the notion of the so-called Planet X may actually be a black hole is absurd, when only stars with several times the sun have enough mass to become one in the first place, and anything with that much mass, perhaps wandering around in the Oort cloud, would surely be obvious now. You are correct. In our current day, astronomers know of no way that a black hole can form by any other process than by the collapse of a massive star. Star dies, it implodes on itself and it creates a black hole. And it's only with that infalling material, it moving it close to the speed of light, that you can actually get the force to create a black hole. And that's all we know of today. One other idea is that you can get infalling material directly that could form a supermassive black hole, but to get the kind of black hole that you would need to form some object that could be orbiting within the solar system, the only possibility is this idea of a primordial black hole. And these are black holes that could have been formed back to the first moments of the universe. And so at the very beginning of the universe, everything was almost of uniform density. But we can see in the cosmic microwave background today that there are little parts that were more dense and little parts that were less dense. And that's what the temperature variations in the cosmic microwave background to refer to. So one idea is at the beginning of the universe, you would have these regions of higher density and regions of lower density. And so the idea is that you would get these primordial black holes that would form in the regions of higher density. And they would be of any size. You could have black holes the size or the mass of a car, black holes with the mass of an atom, black holes with the mass of an asteroid, black holes with the mass of a planet Earth. And then they would be thrown out into the universe and would be free to wander around and cause havoc over time. And so one of the explanations for maybe the planet 9 that we can't see is that it could be a primordial black hole. And that would explain the gravity of some object in the outer solar system that is contributing to the weird movements of the objects out in the Kuiper Belt, and yet would also explain why it hasn't been detected so far. Maybe it's a primordial black hole. But there's not a lot of people that actually believe that that's the case. It's just one explanation. And when you're trying to come up with ideas to explain weird mysteries in the universe, no idea is too crazy. Now, you need to be able to rule them out, and I'm sure the primordial black hole idea will get ruled out eventually. In fact, I've even seen some papers that propose to do that. But just over time, as bigger telescopes come online that are capable of finding Planet 9, no matter how dim it is, and it's probably going to be the Large Synoptic Survey Telescope, the Vera Rubin Observatory, then the whole primordial black hole as Planet 9 argument will disappear. But until then, it's just a cool idea to think about, and it's a cool idea to think that there are these primordial black holes out there wandering the universe today. In fact, there's one theory that they account for dark matter, which is kind of cool. Not many people believe that, but still, it hasn't been ruled out yet. So until then, it's just on the table as an idea. Tomahawk Strike. Amazing how the simulation hypothesis is an accepted thing to speak and speculate about, while the UFO phenomenon is still something people like you laugh about, when the documentation of its existence keeps on getting stronger. The idea of the simulation hypothesis, right, that we are living in a simulation, is just an idea, and it's a hypothesis, and there's no evidence to account that it is real, and so nobody is putting any real effort or energy into figuring out whether it's true or not. It's kind of impossible to figure out. And so that's like literally, it's an entertaining thought experiment that flits into your mind and then you just ignore it again. That's the level of work, of time spent thinking about the simulation hypothesis. Wow, the possibility that there could be life in the universe, like that's like a quarter of the videos that I make. That's like many of the books that I like to read. That's the science fiction that I'm interested in. That is the philosophical conversations that I have. There's SETI. There are astrobiologists who are putting the work. There's a spacecraft going to Mars right now trying to look for life on the red planet. So I think there's more energy being put into, are we alone in the universe, than are we living in a simulation? So I disagree with sort of the amount. Now, I think that the people who say that they have seen UFOs, that there is evidence that there are alien civilizations visiting us today, is non-existent. And I understand that you disagree with me, and that's fine. We can all have different amounts of evidence that it takes to convince us that something is true. And we all get to make that decision for ourselves. I don't get to choose how much evidence it takes to convince you, and you don't get to choose how much evidence it takes to convince me. And so far, I find the evidence unconvincing. But you know, how much time do we spend thinking about it, trying to find evidence, trying to work out what's going on? Like, a lot of time. So I find the question, the possibility fascinating, and there is no scientific question that I want to know the answer to. It's just that when I decide that I know the answer to it, I want to be right. I want to know that the evidence is overwhelming that this thing is true or false. More questions in a second, but first I'd like to thank Kevin Salam, Charles White, Abdulrahman Samoud, Nick Pappas, Joe Stevens, Justin Davis, and the rest of our 892 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universe today. Tug back one. Question. Let's say that there was a rogue planet which was identical to planet Mercury. The planet approaches our solar system and gains velocity, but on its way to the inner solar system, it passes through the outer layers of Saturn. Could the planet survive that without breaking apart, and could it then become a new planet in our solar system? All right, I'm imagining this terrifying scenario. You've got this Mercury-sized rogue planet blasting through the solar system. It approaches Saturn, and it gets so close that it skims through the outer atmosphere of Saturn, aerobraking using Saturn. And the answer is no, it would be torn apart. If you get that close to Saturn, the tidal forces of Saturn are going to tear this world apart, and then it will turn into a chain of debris. But would that chain of debris end up in the solar system? It all depends on the velocity. If it was coming in fast enough, then it would still be on an interstellar trajectory and it would fly back out of the solar system again, but towards a different location. But if it was slowed down enough, then you would have this now chain of asteroids that were orbiting Saturn. Some would come back another orbit later and crash into Saturn, or they would just end up being a new orbital ring in the solar system. But how do you get to keep it as a planet? And in order to do that, you need to do some kind of three-body interaction. So maybe it goes around Saturn, and then also goes around the Sun, and then also interacts with Jupiter in such a way that between those orbital interactions, its orbit gets changed enough that it's no longer interstellar, and it's now just going to be orbiting the Sun like the rest of the objects in the solar system. But it's not going to be a very nice orbit. It's going to have a highly elliptical orbit that brings it like a comet almost, because it was coming in with such velocity from interstellar space that to just be able to capture it, it's still going to be a very extreme orbiting object. But it's a cool idea to think about. Alien. So we're in the Orion arm of the Milky Way galaxy, and when we see that band of light in the night sky, we are looking at a different arm from our own. I need the answer. I'm dying from curiosity. You actually have the answer to your question in the name of the arm, which is the Orion arm. And so when you look out to the constellation of Orion, you are roughly looking towards the Orion arm of the Milky Way, which we are at a spur off the side of the Orion arm. And the rest of the large features of the Milky Way roughly correspond to different constellations in the sky. So when you are looking at the core of the Milky Way, you're looking at the constellation of Sagittarius, which is visible in the summertime. When you are looking out into the outer reaches of the Milky Way, really the opposite from the core, you're looking at the constellation of Auriga. Auriga? I never can get the right pronunciation of that. And then there are a couple of other arms in the Milky Way. I think the Milky Way has at least 2, maybe 4 spiral arms. You got the Norma and Cygnus arm, you got the Sagittarius arm, you got the Scutum Crux arm, and Perseus. And those all correspond to constellations in the sky. So if you can find that constellation in the sky, you're roughly looking at that part of the Milky Way. And so the entire Milky Way, all the way around us, when you consider where we are, we're about 27,000 light years away from the center of the Milky Way, about the same from the outer edge of the Milky Way. And then when we look out in space and when we see the Milky Way, we are actually just looking. We look in one direction, we're looking to the core of the Milky Way. We look in the opposite direction, we're looking out into space towards the outer edges of the Milky Way. And we look side to side, and we are seeing the other spiral arms that we share. But of course, because we're trapped inside the Milky Way, we can't see that true structure. But I'll get Chad to put up a an image. There's a galaxy called NGC 1073, and that is a very close example of what the Milky Way would look like if you could see it from above. Bobby St. Pierre. How are astronauts on Mars going to handle the cold? Their suits must have a larger power source. Actually, Mars isn't that bad compared to the other places that astronauts already have spacesuits. When you think about when you're just out in space on a spacewalk on the International Space Station, temperatures go up 170 degrees and then they go to minus 170 degrees over the course of 45 minutes as you go in and out of the Earth's shadow. Similar thing when you're going to be on the surface of the moon. You're going to be walking around in plus 170 degrees, and then you're going to go into the shadow of your spacecraft, and then suddenly the temperature is going to go down. Now, the temperature changes are due to radiation, and so if you go into a place where now it's very hot and then suddenly it's very cold, you're going to feel that temperature radiate away from you slowly as you slowly cool down. But there's actually an interesting conversation that I had with Terry Virts, not the part in this episode, but actually in the upcoming episode of the Weekly Space Hangout, and he talks about how he was doing a spacewalk and NASA was telling him that he was going to have a moment where the temperatures were going to change dramatically, and just like right away he felt the temperatures change, that he was really cold and then he was really hot, and it's almost instantaneous. It was quite surprising. When you're on Mars, the daytime temperature at noon at the equator is 20 degrees Celsius, which then you actually need like a little bit of air conditioner to keep yourself cool, because you're going to be in this spacesuit and you're going to be trapped like a greenhouse effect around you. But then of course at night temperatures can drop to 100 degrees, minus 100 degrees Celsius. So your spacesuit will need to account for that. And then the other thing is there is some air pressure on Mars. So when you're out in space, the temperature is just radiating away from you, but when you're in Mars, there is air that's going to be blowing against you that can help remove some of your heat. But in general, the heating requirements for a Martian spacesuit are actually less of a concern, which is good news because the gravity is higher on the surface of Mars, which means that astronauts on Mars are going to need a less heavy spacesuit to be able to get around and do things, because they're going to feel more of the gravity while they're walking around. Rachel Wheeler. Hi Fraser, love the show. When we start mining the moon for resources, how much can be taken before affecting the moon effects on the Earth, if at all? So we are gravitationally affecting the moon. We keep the moon in orbit around the Earth, and of course the moon gravitationally affects the Earth, causes the tides. And yeah, if we just started to carve up the moon and remove the pieces away, then over time the size of the tides here on Earth would get smaller and smaller. We still get the tides from the sun, but they're not as dramatic as the tides that we get from the moon, because the moon is a lot closer. And so you can imagine some time if we really completely dismantled the moon, then there would be no more lunar tides on Earth. But that's not possible. And in fact, we will be using resources on the moon, but we're going to be using them on the moon. So we will be digging up the regolith on the moon and then turning that into buildings. We will be digging up water on the surface of the moon, but we'll be using that for breathing and for water. There will be some material that's going away from the moon. You're going to imagine propellants can be carrying rockets away from the moon, but it's going to be a tiny fraction. It would take us billions of years of us trying to harvest resources from the moon before we caused any impact, so don't worry about it. Simon Grindle. Will Pluto and Neptune ever collide with each other? When you look at the orbits of Neptune and Pluto from above, they actually look like they do intersect. And there are times when Pluto's orbit actually brings it closer to the sun than Neptune is. And back in the day, it was like, I remember being a kid, it was like in the 1980s. Anyway, they did that switch over, and for a while, Pluto was the 8th planet and Neptune was the 9th planet. And now Pluto isn't a planet anymore. Poor Pluto. But no, they will never collide, because Neptune and Pluto are in an orbital resonance with each other. So every time that Pluto goes around the sun twice, Neptune goes around 3 times. And the gravity of Neptune is actually keeping Pluto in line. And so they will just keep doing their orbits like they've been doing for billions of years, and they'll never collide with each other. Guybrush Threepwood. Question, how do astronauts deal with ear pressure differences? I have sinus problems and simply driving up a mountain can make my ears hurt. Flights are a nightmare. I can't imagine going up at such speeds. Is the pressure inside the capsule always perfectly 1 atmosphere? Great question. Let's ask an astronaut. Here's astronaut Terry Virts.
So I have good news and bad news. The good news is the space shuttle or the Soyuz or SpaceX or Boeing and the space station, all the vehicles we fly in are at basically 1 atmosphere. So the same pressure from the launch pad is the pressure while you're flying in space, is the same pressure when you get to the space station. Very little difference. So you don't really feel a lot of that. Maybe when you open the hatch, there's a really small, you feel that, but it's minor. Less than what you feel on an airplane for sure. However, if you're going to do a spacewalk, when you go in the airlock, you're at 1 atmosphere, and then they reduce the pressure in the spacesuit down to about 1/3 of an atmosphere, which is a lot more drastic than going up in an airplane. So you do have to be able to manage that. And the way you do that is by doing the Valsalva. You close your nose and talk like this, and then you blow out your nose, and it makes your ears clear, we call it. And so you can't do this in a spacesuit because you're in a spacesuit. So there's this little foam thing that we glue onto the helmet. So you're in your spacesuit. And then when the pressure is changing, when you're depressurizing to go outside, most importantly, when you're repressurizing to come back inside, you stick your nose in this foam thing and you can clear your ears. So that Valsalva device, some guys can just do that and clear their ears, but I always use the Valsalva device as a way for like artificial fingers. So that is definitely an issue. If you can't clear your ears, you won't be able to do spacewalks.
All right, thanks, Terry. It was great to hear your personal experience. Of course, if you want to see a longer interview with Terry, check out the Weekly Space Hangout. Hopefully it'll be happening next week after this show comes out. So give that a watch. All right, that was awesome. I hope you enjoyed that. My brain, I have to get back into the practice of answering these questions. Just a month away from this, and I'm already a little slow down. Anyway, thank you everyone who sent in their questions. I really appreciate it. As always, if a question pops in your brain, just write it down. I'll gather them up and I'll answer them here, and I will see you next week. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes.